correct?
Yep. You guys, UT Arlington?
Can you guys hear me okay?
Can you hear me now? Yes, we're UT Arlington. Yes, sir.
Okay. All right. And you have most of your team representative? You're good to go?
Yes, we're waiting on one more person, it looks like.
Right.
But we can go ahead and get started whenever y'all are ready.
Okay, we'll do that. And if we're asking something and you want to defer to that one person, we can come back to it if you want. But
all right,
we're kind of short on time, and I'll apologize numerous times for that. but it is what it is. We didn't set the rules, so
completely understood.
First question: your overall design of your rocket contains multiple complex electronic systems. How did the team determine that all the electronic systems would successfully function simultaneously and were mutually compatible under actual flight conditions? And EMI, EMC system testing are some of the particular things of interest. And I'm going to go put my dog out so he's not bothering you. Sorry.
Okay, all right. No problem.
Go for it.
So in terms of Stratologger, and those are our main flight computers, were just our two Stratologgers. We've had a lot of experience with flying those. In terms of GPS on our payload, Sudarshan or Nahal, can you all discuss any testing we've done with those? Or Nahal is I'm the chief engineer. Nahal was our payload lead. Apologies for that.
Yeah, I can talk about the GPS. So for the GPS on the payload, we had a GPS system, an accelerometer as well. And when we were testing it, we went out to the launch field, made sure that the GPS actually could get a fix while we were at the launch site. We also made sure that we could get a fix before we went out to the launch site as well. And with all the other sensors, we tried to do a very small drop test, and that was successful, and none of the accelerometers hit a range limit. So that's most of the tests that we did.
So I guess in terms of cross-compatibility, we didn't do any testing to make sure there wasn't direct interference, but we knew ahead of time that they wouldn't interfere.
Mm-hmm. Yeah.
And you knew ahead of time because?
Nahal?
We knew ahead of time. We knew ahead of time because our payload was all the way up close to the nose cone, and we didn't really think it would interfere with the Stratologgers or any of the other electronics.
Was the placement of the Stratologgers and the other components was that purposely done because of that, or was that just it was done for other reasons and it just happened to be that in terms of compatibility?
More so that it was just, we knew that our coupler electronics were going to be in the coupler, and then the payload was going to be in the upper end of the rocket. It wasn't done purposely for that reason.
Okay. I'm going to go on to the next one then. It says here, you had a 10K flight.
Yes, sir.
And on your last launch, and you did not make your altitudes. My question is, what post-flight analysis have you done? And I know there in your presentation, you talked about that you were thinking that a camera might have affected you. And if that, in fact, is the question, my other follow-up to that is, why didn't you consider the camera? And lessons learned, I guess. Anyway, okay. I'll let you answer the question instead of answering for you.
For sure. So there's a few things that we're thinking would be the case. Like I said in the presentation, the camera, we didn't taper our leading edges of the fins because in open rocket, we were getting the correct altitude. So we thought we would be sufficient, but like I said, we didn't taper the leading edge of the fins. We had extra weight in the nose cone to restabilize it because we ran into some issues on the launch pad with stability and that extra camera. We haven't done true post-flight analysis to show that would get us to 10K. That is something we plan on working on over the summer because we don't have a good way of creating a taper edge on the leading edge yet of our fins. But that is something we're going to explore over the summer for sure. But in terms of considering the camera as an extra element of drag, that is something I thought about ahead of time, but I didn't have time before we were test launching to make an aerodynamic cover for it. So that was just put onto the rocket.
Did I hear you say that you had some balance issues on the pad and you corrected for those?
Yes. Well, not on the pad, at the launch field.
Okay.
Yeah. So
okay.
On our open rocket design, I don't know if this is, yeah, this is the updated one. So if you'll notice, I don't know if you have it open, but on our slides, we had the open rocket design and the fins look a little far forward. And so during the manufacturing process, the fins were put a little too far forward and that threw off our stability. We were able to correct it by adding weight in the nose cone, which is, as I mentioned, was probably another reason why we didn't reach our altitude goal.
Okay. All right, the next question, you had a MATLAB fin simulator that you've used to design your new system due to your failure in 2019. My question is, have you gone back and used your 2019 design in your fin simulator to validate that it failed, that it would have failed?
No, we have not. But actually, I'm going to write that down because that is definitely something we should do.
Okay.
Sorry about that. But yes, that is something we should definitely do. But we have not done that yet. No.
Okay. Well, that's a good answer because that's I was going to say if it didn't fail, I'm going to say, well, then you got a question.
Exactly. Yeah.
So you have a good non-answer there. I'll have to concede that one to you. Okay. Next question. If we told you that your mission flew but failed, what would you expect to be the most likely cause? And based on that expectation, what have you done to address that likely failure mode?
If our mission flew but failed, what would be the likely reason it failed? Is that
right?
Okay.
So you're not at the field. Your team flies for some reason. You're not there, but they call you and say, we failed, and you'd say, oh, I bet what failed.
Mm-hmm. Based on our previous experience, I would have expected it would have been the fins that would have failed, just because we weren't able to do true stress testing on those fins with or true experimental testing on the fins. It was more just kind of analytical using MATLAB, as I mentioned. So that would have been my expected failure. And what we would have done to prevent that in the future is, like I said, be able to take it to do like a 3-point bending test or put it in a wind tunnel if we had access to that, but do some sort of testing to validate our calculations, physical testing.
Okay. Any other thoughts from anyone? Any other areas on the team?
El-Shadday?
First off, same answer with the fins. Secondary point would have been maybe electronics. It's like earlier in the year and in past, we have had like electronic failure, just like wiring issue, component failure. We got new wires, and our Stratologers were working fine when we tested them, but we've had like launch pad wire get messed up in the past years.
Okay, I had a little trouble hearing that. Did Steve or Chris, could you guys hear that? You're kind of breaking up. I don't know, maybe you want to try again, maybe a little closer to the speaker?
Or? Do I sound better now?
You do. Yes, that's great. Thanks.
Okay. Sorry, I switched off the headphone mic to my actual laptop. Okay. So first point of failure would have been the same as Alex, was the fins. Secondary would have been electronics, because we've had wiring issues in the past, or just like a component failure. Like we used to use a Big Red Bee, but that's like failed back in November. So that's a big part of the reason why we use 2 Stratologers instead of 1, just to have a secondary system. But yeah, no, we've had wiring issues in the past, but we've tested all the components, so we thought that would be fine. But if there was just failure on the pad, I might have assumed that.
And I just want to preface that is El-Shadday Zareh. He's our structural analysis lead. Okay. And then we've got Rodrigo Ramirez, who's our aerodynamics lead.
Okay. Do you guys have any test flights coming up?
Nothing. We may do another one during the summer if we make the improvements that we're considering making, but not officially, no.
Okay, that's what I was curious, because it sounds to me like there's some significant amount of uncertainty on the fins still.
So the uncertainty comes from, as you'll see by our design, we have the internal fin can. So I guess the uncertainty comes with we didn't have the tapered edge, we didn't have fillets on the edge of between the fin and the fuselage, just because it has the internal structure. So there was a lot of uncertainty as to whether we would run into the flutter issue again. That's why this flight was largely to validate that this current design wouldn't receive that same failure.
Okay, that's fair. Okay, we'll throw one more question here, and we still got a little bit of time. So a little bit more non-technical maybe, but so COVID presented a unique challenge to this competition. Can you briefly describe any unexpected opportunities that you gained, or any unexpected challenges that presented to your team's preparation and process?
Well, Rodrigo, you're in Houston. Do you want to discuss any challenges with COVID related stuff?
Yeah, I think the biggest challenge was to be helpful in the team, you know, being 200 something miles away from where school is at. So it was pretty challenging to be online, right, and to help the team out while most of them were in the DFW area, you know, assembling the rocket or having meetings in person if possible and other things.
So how'd you handle that?
Well, luckily I had exams over there at campus from time to time, so that helped out to talk to them in person or be there in person. And for like major launches, well, at least for one major launch, I actually made the date to go up and to help them out for that.
Okay.
So a little bit of schedule planning for sure was involved in, yeah.
That, in addition to that, just we saw a drop in numbers significantly. Usually at the beginning of the year, we could have some sort of gathering where we get a lot of new members, and then we get like 5 to 10 people in each sub team. But this year, it came down to largely the leads, and then maybe like 5 extra people that were in the lab at any given time. So just scheduling a time to get everyone in the lab at once to work on something was very difficult, and a big challenge we had to overcome for sure.
Mm-hmm. Well, little real world experience is always good, right? All right, I think we're about out of time. Does anyone have follow up? Go ahead, Steve.
Just real quick follow up. I think we might have a little bit more. What about any positive aspects that you didn't see coming in terms of anything good happen as a result of having to deal with COVID related issues?
I think a shift into, getting to use more online platforms has been helpful. I guess having everybody, it forced us to really look at how we're recruiting and how our structure is working for the team. Because if it comes down to a point where we're receiving less numbers, we should be reevaluating how we're recruiting and looking at the stress load on our leads and our leadership overall. So it forced us, I think a positive is it forced us to take a step back and reevaluate how we're leading the team, how we're recruiting and marketing ourselves, and how we're placing in different competitions as we go throughout the year for sure.
Add to that real quick. One thing a positive would be documentation. Our team already had a good history of documentation with our Google Drive and a lot of past documents, but with all meetings being online on shared documents, it only increased. So we can really see the entire process throughout the year.
This wasn't a question we were going to ask you, but I'm just more curious. How much time does this consume compared to class time? And I see you're already laughing, but can this become an obsession?
Well, certainly. The thing for us is we do participate in 2 competitions. We do NASA SL and Spaceport America Cup. So it does become a bit challenging balancing both, especially, NASA SL is largely throughout the year, and then Spaceport America Cup is right at the end. So it does consume, I like to say for chief engineer, it becomes like a full-time job almost, just with the amount of reports you're constantly writing and stuff like that. But we have passion for it. So it's
worth it. Right?
Exactly.
How many times do you get to see a rocket fly? Right?
Exactly. Especially going 10K. It's a sight to see.
Yeah. Mm-hmm. All right. Well, that's great. I appreciate it. Enjoyed talking to you guys. Look forward to seeing you out in the field next year.
Yes, sir. We look forward to it. Thank you for having us.
You guys will be the only ones that'll think it'll be cool. It'll only be 100 degrees, and you're probably used to 105, aren't you?
Exactly. It's already 110 over here. So
is it 100? Ooh, okay.
Yeah. Mm-hmm.
All right. Well, thanks again. Appreciate it. And like I say, we'll look forward to to seeing you next year.
We look forward to launching. Thank you for having us. Y'all have a good day.
All right, you
Thanks,
too.
guys.
Take care.
Bye-bye.
Good job.
Thank you.